In this video, I'm going to demonstrate for you the incenter of a triangle. Okay, so we're going to start by constructing a triangle. So I need segments. Okay, now the incenter is the point of concurrency between all the angle bisectors in a triangle. So I'm going to be constructing 3 angle bisectors in my triangle. So there's the first, here's the second, and there's my third. Okay, and I'm going to mark my point of intersection there. All right. Now, what I know, so this is what we call concurrency, when all of the segments intersect at one point. Okay? The point of intersection for the angle bisectors is what we call the incenter. Now, we know that any point that lies on the angle bisector is equidistant to the sides of the angle. And in this case, the incenter, which is the point that lies on every angle bisector, is going to be equidistant to each side of the triangle. Also remember that a distance is measured with using the perpendicular segment from the point to the line. So what I need to do is I need to draw some perpendicular lines here from my incenter to the side of the triangle. Okay, so I wonder if I could change, I'm going to change that color to red. So I'm going to make my distances, my perpendicular lines, red. Good. Okay, I know there's a lot of lines going on here, so what I'm actually going to do is I'm going to draw some segments over them. So actually I need points first. So this point, nope. Where's the intersection? There's a point. There's a point, there's a point. Because then what I'm going to do, there's so many lines, and I'm sorry for that, but that's how it has to happen. So I'm going to hide this line, because I already have the segment there. I'm going to hide this line, and hide this line. Okay, so there's my perpendicular, the points that I used, right? So here's perpendicular, here's perpendicular, and here's perpendicular. And let's change those perpendicular distances to red. Just trying to make it visually for you guys to see it a little bit better, see what's happening. Okay, so my red segments are my distances from the incenter to the side of the triangle. All those distances should be equal to each other, okay? And we could check that out actually by doing some measurements, right? So if I measure from the incenter to the side here, now that it's in my way. Okay, when I move this guy, oh, of course it's going to stay right there. Okay, so let's move this one there. So they're all 1.48. How wonderful, okay? Now watch what happens if I move my triangle around. Notice the incenter is staying inside the triangle, and all of those distances from the incenter to the side of the triangle are staying equal to each other. Okay? That's the special thing about the incenter. Right? Incenter. Alright, now another really cool thing about the incenter is that it becomes the center of a circle that's inscribed within the triangle. So if I watch what happens. So if I were to get a circle here, okay, circle, I just want a circle. All right, oh geez, what did I do? Boom, get out of there. Okay, I want a circle where the incenter is my center. Okay, if I move from the center of from the incenter as my center of the circle out to one of these points that it intersects with the side of the triangle, like right there, any one of those, you'll see that it creates this circle. This circle is what we call inscribed inside of the triangle. Inscribed means that each side of the triangle is tangent to the circle. And we'll talk about tangency in chapter 10, but just quickly, what it means is that it intersects the side at only one point. Okay, so you can see that that's what's happening. And if I manipulate my triangle even more, you'll see that that circle stays inside of my triangle as well as the incenter. It's inscribed within the triangle. That's pretty cool, actually, how that works. And I could drag this one, see? Boom, 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 staying inside of the triangle. So those are just some cool facts and things that we do with Incenter. Oh, I don't want that. I already did that. All right. See you later.